the next few talks, there's probably going to be pizza at these. So if you were joining online and want to come and get some free pizza, come on in person to the next one. But with that, I'm going to go ahead and get started. So we'll do a quick introduction, if I can do that. So real quick, who am I? So my name is Aaron McCanty. I'm a cybersecurity researcher at Patel Memorial Institute. Prior to going to Patel, I did some work in software development before finding out that I really hated software development and wanted to break stuff instead of build it. So I'm also have taught a couple classes over here at OSU, EC 5567.01 and .02. That is offensive security and reverse engineering and malware analysis. Really awesome classes that Patel helped to create, which is phenomenal collaboration between us and OSU. I did graduate from Ohio State as well, not that long ago. I graduated in 2017, so I'm still familiar enough to know that everyone loves Adriatico's pizza for their events. So my job mostly entails what is called reverse engineering and vulnerability research. And I'm going to get into what that is in this talk and what exactly I do on a day-to-day basis. And more specifically, I focus on Internet of Things, IoT devices, binary exploitation, machine learning, and embedded systems. So those are kind of my areas of interest and expertise. And you can see I've got, kind of me by day and me by night over there on the side. As any good hacker, I kind of live in the black hoodie. It's kind of our uniform. So I'm not going to dwell on this too much, but just as in case anyone didn't know, Patel is the world's largest nonprofit research and development organization. We're actually a charitable trust that was created from the will of a guy, Gordon Patel, when he died in 1929, left a whole bunch of money to create Patel. Our headquarters is about 2 blocks south of here on King Avenue, which makes it really convenient to come over here and do talks like this. We do work in national security, Cybersecurity, which is chemical, biological, radiological, and nuclear defense, health sciences, medical devices, critical infrastructure and environment, basically anything you can imagine somebody does research in, somebody at Patel is looking at it. We're responsible for a lot of the technologies that you guys are familiar with. We helped create cruise control, Xerox machines, CD-ROMs, barcodes, and my personal favorite and the most revolutionary game-changing of them all, little dimples and golf balls. That was a Patel invention. So we're here to talk about cybersecurity and what exactly it is. And the reason that we're doing this is, and the reason that Cybersecurity Institute Trust wants to create this speaker series is because everyone has a different definition of cybersecurity. Nobody really knows what it does. Everyone has a different opinion. When you say cyber or cybersecurity, everyone has a different opinion or idea of what that means. And this kind of can be pulled down into, there's a lot of things that can fit within the cybersecurity bubble. And some of these things have overlapping similarities. Corporate IT security, penetration testing, they have some similarities. And my catch-all, I just call it the Geek Squad, but there are dozens and dozens of career paths and opportunities for people. Everything from, we have people working in cyber that are physicists and mathematicians and software developers and reverse engineers and hardware security experts and everything under the sun. But there is one thing that all of these different career paths have in common. Does anyone, any guesses on what that is, what that one thing is? That one thing is that this is how you see yourself, but this is how the world sees you, right? You think you are the protagonist in Mr. Robot, while everyone else thinks you're Moss from IT Crowd. And there is some truth to both of those, right? And I know that because Mr. Robot was basically based off of my life. The point being that all these different career paths have vastly different things that they do as their day-to-day job. There's different skills that go into it, different things that you need to know and learn how to do, completely different skill sets that build into these. And ultimately, if you look at what I do for a living and what a IT specialist in corporate America does, they're vastly different. There's almost nothing related at all to what we do. So bundling all these things under cybersecurity is kind of missing the point. And it's also not giving you guys a fair understanding of what options are there available in this field. When you see stats like, there's 700,000 unfulfilled jobs in cyber around the world, or in the US. So what does that mean? What other jobs actually entail you doing? And that's kind of what this series, the speaker series, is kind of giving you guys the tools to answer now. So what is reverse engineering? That's what I'm here to talk about. This is what I do every day. By definition, reverse engineering is the process of decompiling something into discrete parts so they can be documented and understood. So that's a pretty broad definition again. So why exactly do we do this? You know, we can be looking to analyze something, we can looking to investigate something, discover how something works, but ultimately we're looking to understand something. And you know, reverse engineering, while I apply it to software, I do software reverse engineering and try to understand what software is doing. This same concept can be applied to basically everything you can imagine. We've got hardware reverse engineers, software reverse engineers, algorithm and protocol reverse engineers. And you can pick apart and try to pull apart and understand everything, you know, whether that be software, hardware, video games, art, business, OSU's admission program. Any of these things can be pulled apart, analyzed, and understood. And that's ultimately what the goal of the reverse engineer is to do. In cybersecurity, reverse engineer ultimately seeks to answer questions that people might have. Those questions might be, hey, you know, somebody in the IT team found malware on your network. What does it do? What is it looking for? What data is it collecting? Maybe you're working in a video game company and somebody wrote an aimbot for your video game, right? How does it avoid detection? How does it get around your anti-cheat mechanisms? Maybe you're a software developer and you inherited legacy code. You know, how does it work? How do you actually interact with it? How does this tool work? The guy that wrote it, you know, left the company 20 years ago. How does it actually do anything? Maybe you found a Raspberry Pi in the network closet. Who put it there? Who's trying to break into your infrastructure? And you know, most important thing here, auditing software is easy when you write the source yourself. When you have source code to look at, it's really easy to audit that. You can take a look at it and audit that. But if somebody else wrote that code and you're trying to incorporate it into your system, how do you audit that when you just have a compiled binary and you don't have the source code that created that? So these are some of the big questions that I am tasked with looking at every day. And I'm not going to bore you guys with a complete death by PowerPoint. I do have some interesting stuff to show. So I'm going to pull up a hex editor and we're going to look at some examples here. All right. So we're going to start off with a pretty easy example. I have a program here, program.c. Up on the top here, I've got a code editor, you know, basic VS Code editor, and then down the bottom, I'm actually running a Docker container that is a Linux virtual machine so that I can compile and run this thing for you guys all within the same screen here. So this program is very simple. We've got a main function here. It says, hey, welcome to my amazing guess a game. Are you psychic? It gets some user input from this function. It then checks the user input with this function. And if it's correct, it prints out nice job. And if not, to try again. And if we scroll up here again, we've got the source code here. We can see all it's doing is checking the user input to be 1, 2, 3, 4, 5. So if I compile this, we've got the compiled binary now, that a.out file. If I run that, it's going to say, hey, you know, welcome to my amazing guess the game. What's your guess here? I'm going to put in a bunch of random numbers. It's going to ask if I'm sure about that. And no, it's not the right thing. Try again. But, you know, I know the answer because I've got the code here right in front of me, right? So if I run this again, and 1, 2, 3, 4, it'll say, yeah, nice job. You got the answer. You knew exactly how to put this in. You got the key, right? That's awesome. That's really easy. But what happens if I don't have the source code? So I'm going to get rid of this for a second. So in here, I've got an unknown binary. So if I run this thing, you can see it's the same program. But if I enter the same guess I had before, it's not going to be correct. This thing was compiled with a different key, a different password that it was looking for. And how am I going to get that? Well, I know that this thing is not magic, right? All of the logic to determine if my input was correct that is contained somewhere within this thing. So, you know, how do we start pulling it apart? Well, one thing we can do is look at the actual assembly or machine code that this thing is made up of. So these are the ones and zeros that program is compiled down to. So when you write the program and then say, hey, GCC, please compile my source code into a binary, the compiler takes your program in and outputs this file, which is literally just the ones and zeros that your processor interprets and then runs and does everything it needs to do to run your program. You can see actually some of the strings in here that are related to what we're looking for. You enter your guess here, welcome to my amazing guessing game. These are the bytes that represent those characters. But if I'm sitting here looking at this thing, there's not a whole lot that jumps out to me as super useful. Well, I could sit here and analyze each bit one by one and determine where the logic in here is that's checking my input versus something else. There's a lot of tools that automate that process and do it for us. One of those is Ghidra, which is an open source tool created by the NSA and put online. It's on GitHub. You guys can download it and play around with it as well. So if I open up this unknown binary in it, what Ghidra does is that it takes that compiled binary, you can see it on the left side here, and then pulls out information that might be relevant to me. So one of the things it pulls out is all of the functions. I can look for main. Oh. If I jump to it, sorry, my computer's being a little laggy here. All right, so on the left-hand side, you can see these are the bytes that represent all the code that was in that function main. And Ghidra does one step further for us. It actually takes all this code, all this machine code, and pulls it up and turns it into C pseudocode, which looks quite similar to my actual source code, right? This is essentially looking at source code. So to the point where Ghidra is actually able to tell you function names, right? It's got the get user input function there. It's got the sleep function. It's got printf. It's got puts. It's got all these things along with the strings that are in that program that tell you what it's doing. You can very easily tell what's going on here. So we know that inside that check user input function, it's comparing it against a value, right? And I just need to jump in there and see, oh, look, it's comparing whatever's passed in with X539, sorry, which in decimal is 1337, the classic hacker value there. So if I jump back over to run unknown again, 1337. Look at that. We cracked our first code, right? We understood, we ripped it apart, we figured out how it worked, and now I know how to use this thing. I know how to break into it. If that was a password that was getting me access to a system, now I've got the password. We can take this a couple steps further, and there's a lot of things. Obviously, that program was very basic. It pretty much was just reading an input, checking that input, and seeing if you enter the right thing. We can go one step further here and do a little bit more. Of another binary here device, if I run this one, it's got a little bit more. Again, we're presented with essentially a password check on the first, as soon as you run it. It asks you for a PIN. This is says BitTech personal communicator 10G enabled. They're twice as fast as 5G. And I can just try to enter a PIN here and, okay, invalid PIN, it's not gonna work. So let's go back, let's jump back into Ghidra. I can open up this function or this binary as well. And again, we get presented with all the ones and zeros that make up that program. I can again search for, it's annoying, you guys are seeing. Great. Jump into main. And compile this. And again, pretty basic main function. It has a locked menu that it prints out first. And if the return value for that is 0 or not 0, it goes into this unlocked menu. So if I go into this locked menu, it says, okay, look, here's where it's printing out that BitCheck personal communicator 10G enabled. And then it calls another function called pin check. Let's jump into that one. And here we can see it prints out enter pin. And then down here, after it does a comparison, a string comparison, it prints out access granted, hello Marty. All right, so that's my goal. That's where I want to get to, right? So I want to figure out how to get down there. And how to get down there is if this I bar 1 equals 0, which is the return value of this string compare. And the string compare is comparing the result of this fgets, which is reading input from the user. It's comparing the result of that to whatever this local 38 variable is. And that local 38 variable is apparently up here set to be 2, the ASCII character 2. So if I go back here and try to run this thing again and try to put in 2, oh, it says it's still an invalid pin. So we're not quite there yet. We're not completely understanding what's going on here. And the next thing that I'm gonna point out is that string comparisons in C programs usually go until, or they interpret a string until it sees a null character. In C programs, all your strings are null terminated. And the reason for that is because all these functions are reading a string until it gets to a null, and that null determines the end of the string. So if we start reading a string at this local 38 variable and start going down these local variables, we can see these values here are also contained within that all the way until we get to this first null character. Now, hex 31, as it turns out, can also be interpreted as a character, and that character is the value 1. And same thing, if we go backwards, this 2 can actually be interpreted as the hex character 32. Nice thing about hexadecimal mappings with numerical digits is they're all mapped at starting at hex 30. So 30 is 0, 31 is 1, 32 is 2. So we can pretty easily run down here and see this is actually looking for 2, 1, 2, 0, 1, 5, 0, 4. Let's put that in. 2, 1, 2. What was it? 0, 1, 5, 0, 4. 0, 1, 5, 0, 4. Oh. All right, where am I typoing? 2, 1, 2.
0, 1, 5, 0, 4.
There we go. All right. With a little help from the audience, I figured out how to type. So using that, it gave us an access granted, and it went back and called that unlock screen, which is phenomenal. We're further into this program. We can start looking around. It's given us a couple of options. I can try to place a call. It says no service available. Try again later. Okay, view contacts. Okay, so there's some contacts in this phone. I can look at the missed calls. There's one missed call from Doc, and yes, if you guys haven't picked up on it, this is a Back to the Future, themed problem. And if I check view messages, we can see there's a message in here. Marty, it's Doc, no time to waste. Open the flux capacitor hatch, follow the manual override procedure inside. You'll need this 614 con with strange access patterns inside some brackets there. So this is actually an example of a CTF problem, or capture the flag problem. And these problems are very common in the reverse engineering world. They are creative problems intended to teach people a skill or give people a place or chance to learn a new skill or practice something like reverse engineering. And the goal is to find a flag, to capture the flag that's hidden in the program. In this case, we needed to find the pin. We found the pin, we got into the system, and there's our flag. And you could then take this, it was presented at a conference called 614con, and turn that in for fake internet points. And you won the game then. You got your prize. Now, this is all pretty contrived, but you guys can hopefully see how this might be useful to apply to real world things. And in fact, I do have an example of another real world thing that we can take a look at. So I've got some firmware here for a device, and this device is a D-Link router, a router that your home router is running. This might be what you're using at home. You probably heard the phrase D-Link or Linksys or Netgear. Little IoT device sitting in your house. Everyone has one. And what you probably don't know, or what you might not know, is that most of those IoT devices, like routers, like your cameras, like your smart speaker, like Alexa, most of them are running, some kind of operating system on them. And in a lot of cases, that operating system is actually just Linux. So this router in particular is just a Linux box that is set up and intended to, route your internet traffic the way that you need to. D-Link, like a lot of IoT device manufacturers, post updates for their equipment online. So you can go to D-Link's website, look at their support page, and download a update for your router, and then apply it to the router. And that comes with all the new security enhancements and features that they want to give you. And I went ahead and did that. I downloaded a update for this D-Link router. You can see this is D-Link DIR 890L. That's the model name, hardware version A, and firmware version 103 B07. And it came down as a zip file. So of course, we can unzip that. And inside there were a couple of things. One is a release notes PDF. I'm not particularly interested in that. And the other thing here is this .bin file. And that .bin file, if the one thing is the release notes, then the other thing that is there is probably all the code that's going on, all the firmware that's getting put onto that router. So that contains all of the information that router uses to keep you safe and secure from bad guys on the internet. So I want to start analyzing that. I want to start seeing if they're doing things right, if they have hard-coded backdoors in there that people can use to break into your system, or if there's vulnerabilities in that platform that people can use to get onto your network and install malware. So I want to analyze that. I want to audit that. But if I look at this, if I start looking at this thing, this does not look like an executable file. It's not just a program. There's something more going on here. In fact, the bytes here look so random and there's no patterns here. This probably means it's either encrypted or compressed. So I might not be able to understand what's going on here or how to actually interpret these data. These things are not, these bytes are not valid operations. They're not valid opcodes that your processor can understand. So we need to go a little bit deeper on how to actually analyze this. And this kind of makes sense, right? D-Link, they're not idiots, right? They put this stuff out there. They know people are going to try to analyze this. So they don't want to make it easy for people to analyze their software. They want people to have an easy time finding vulnerabilities in their code. Now, unfortunately for D-Link, they're not that smart. So what they've done here is actually just encrypted or compressed their data. It's not actually encrypted. So I have a nice nifty little tool here called binwalk, which is another open source tool you can take a look at. And binwalk, what it essentially does is scans an unknown file and tries to throw every type of decompressor that it has knowledge on at it, and sees if anything intelligent or something that looks valid comes out. So it's going to go say, it's going to try to throw unzip at it. It's going to throw 7-zip. It's going to throw gzip. It's going to throw tar at it and try to just do all these decompressions on this file to see if there's any data that comes back. And as you can see, it's working. It actually starts pulling out information about this thing. So some of the things that it can find, let's see if I can. So right off the bat, at an offset into this thing, it found LZMA compressed data. Cool, awesome. We've got some actual things we can look at it. If we go a little bit further down, it actually found a Linux kernel version. And another interesting thing here is that Linux kernel version is very old, 2.6.36, which is an incredibly old version of Linux kernel, which is also not very uncommon in IoT devices. It's got a bunch of other things that it can find here, but ultimately it was able to extract some stuff. And what it gave us was the root file system for this router. The way that D-Link puts out software updates is that they just release an entire new image that then is applied to that router. And this image is the root file system. This is the operating system that is running on that thing. So in here, you can see all of the binaries, all the programs that are on here that are actually running and routing your internet. Inside of, let's see if I do, if I look at all the files that are in here, we see there's a whole lot in here, including very interesting things like IP secrets and there's a couple of other things.
On the nose name.
What's that?
It's an on the nose name.
Yeah, exactly. IP routes, the password file for this, config files. I think down here further we might be able to find. There's a couple of other interesting things. I'm not going to dwell on this too much, but essentially, we've got all of the code, all the programs, all the configurations, all the certifications that this router uses to validate internet traffic. And if I can find and start analyzing this, then I can start looking for vulnerabilities in this thing, which is, again, essentially what I do day to day, is take a look at IoT devices like this, embedded systems like this, understand how they work, and then look for vulnerabilities in those systems. So with that, I'm going to jump back over to some slides. Come on. So one thing I want you guys to definitely take away from this is that the tools that I demonstrated there, Ghidra, actually, I've got a list here, Ghidra, Docker to make a little virtual machine, or VMware VirtualBox, binwalk, all of these tools are free and open source. You guys can download these, play around with them, and do exactly what I did here with any software that you want to take a look at. And that's actually one of the best ways to get started doing this is write a program and then throw some of these tools at it and see what it looks like. Compare your source code with what was generated and what Geeter is able to analyze. And one of the things that a lot of people don't realize is that this thing is even possible. You know, a lot of people think when you hit compile, it's done. Nobody can understand what's going on in there. That's just machine code, right? But in reality, it's really easy to analyze and understand. And if you just compile something, things like your function names just get included in there and making it even easier to understand. Now, there's a lot of things you can do once you start understanding that, like asking your compiler to strip out function names, then all the function names get replaced with generic, just random function names, which makes it harder to reverse engineer. But if you don't know how to do, or don't know that that's a possible way that your code is analyzed, how are you going to know to look at doing that? So next question, how do you get started doing this stuff? I already talked about, play around with these tools yourself, see what they're capable of. But there's some useful skills that you can look to try to gain while looking at these or trying to get into this field or trying to get started on this stuff. And one of those most useful things is a fundamental understanding of computer architecture. So that is, when I look at code, like I saw that compressed data for that firmware, I can very quickly tell that does not look like valid machine code. And the reason I do that is because I have a pretty good fundamental understanding of computer architecture. I know what machine code looks like. I know what the processor is doing when it's reading in those ones and zeros. And on top of that, along with that basic C development knowledge, some forward development knowledge is required. Because if you're just looking at source code, but you've never written source code before in your life, it's going to be still really difficult to analyze. So you do need some forward development knowledge. Some things like this, so knowledge of Python. Python's a really great scripting language. It's very quick to get going. You just need like 1 or 2 lines of code and you've got a full Python program that's able to do an incredible amount for you. One architecture like x86, most of your guys' laptops are probably x86 or desktop machines are x86. A lot of IoT devices, including cell phones, run ARM chips. MIPS is another popular architecture. All these things, particularly like x86, you'll learn in your systems class if you're doing the CS track here at OSU. Knowledge of algorithms is useful, again, understanding how people will approach problems or understanding what for loops do and how to process data like that. Debugging software is very useful. You guys are probably going to hate using GDB if you haven't yet, but it is one of the most powerful tools out there. And again, basic core development knowledge and ultimately curiosity, right? Because a lot of this stuff, you don't need, a fancy, rigorous defined learning environment to learn this stuff. While that stuff does help, really, you can learn all this stuff. It's all free and available online. All the tools that I use and all the tools that I use in most of my day-to-day life are free and open source. And really, you just need a Google search and just be able to start digging into some of this stuff and ask questions. That's really the best way to get most useful skill in this field. I already mentioned, a couple of those problems that I showed and a couple of those basically password crackers are essentially capture the flag competitions. And capture the flag competitions are cybersecurity's way of introducing challenges and learning new skills in a safe and fun way. These got started because a lot of these skills, the reverse engineering, one of the research skills, are often seen as the dark arts of computer science, right? They're the hackers. We don't want to be teaching that. So a lot of places like Ohio State, universities often didn't want to be associated with teaching these skills. So they kind of put a blind eye to it. Now that kind of attitude is changing. OSU's come a long way. You saw I actually teach or have taught a couple of classes here related to the exact topics I'm going over here. And that attitude is shifting, but CTFs are still around. If you go to ctftime.org, is a very awesome website. It tracks upcoming CTFs and results and write-ups from previous CTFs. And if you go on this website, take a look at the upcoming stuff, you'll see there's probably 3 or 4 CTFs that organizations are putting on every single weekend. We also, Battelle has a bunch of CTF problems up on a permanent CTF site. If you're here in person, I've got some cards over there with a link directly to it. Online, if you just Google Battelle Cyber Challenge, you can find a link to it as well. I can show you guys real quick. We've got some pretty fun themed problems up here. things themed around Monty Python, Humpty Dumpty, Headless Horseman. My personal favorite is the Billy Goat Challenge, Feed the Billy Goat, Feed the Magical Goat. That's a great one to start off with if you guys are interested in trying out some reverse engineering problems yourself. Essentially, you just have to figure out how to feed a magical goat and then what it's looking for to be fed, essentially a password cracker. But that's a really great one to start with if you want to start playing around with these tools. Jump back over here. We're not going to just present. OSU also has some fantastic resources for gaining some of these skills. So I mentioned CTF before. OSU does also, the Cybersecurity Club hosts their own CTF called Buckeye CTF. That occurred a couple weekends ago. They're still going over some of the problems they had in their weekly meetings. So if you guys are interested, definitely jump into those, take a look at that. And the Hackathon and Makeathon, both of these events are great ways to give yourself an excuse to explore these ideas. And we've seen a lot of people go to hackathons and build out or try to use or develop, scripting to use some of these tools, add some functionality to Ghidra or, utilize Binwalk to analyze something. These are great projects to give yourself and work on at one of these hackathons with a group of friends in a structured environment. Same thing with the Makeathon, more hardware focused, but both of these events are great ways for you to explore things you might be interested in and also, give you something to put on your resume that sets you apart from every other student at OSU. Also, there's some great interest groups here related to cybersecurity, the OSU Cybersecurity Club or the Women in Cybersecurity Club. They've got some awesome industry speakers. They do organized CTF participation. They do workshops on teaching people skills and how to use different tools. Very fantastic clubs. I'm over there talking probably once or twice a semester as well on some pretty in-depth topics on that. So if you're interested in anything that I talked about today, definitely check out those clubs. And then here are some of my personal favorite classes here at OSU. These are classes that when I took them, these are the ones that I referenced the material for and have helped me in my day-to-day job every single day that I work. And that is the Systems 1 and 2 classes, which teach you a fundamental understanding of C programming and also debugging and architecture. And then Systems 2 does operating systems and how operating systems work. 3421 is Introduction to Computer Architecture. That goes more in depth on how the processor actually interprets ones and zeros. And then, of course, I've got to give my personal plug for the classes that I teach, particularly the CSE 5477.02. It's cross-listed as the ECE class as well. So I had the ECE number earlier. Here's the CSE number. And it's a class dedicated to these skills, reverse engineering and malware analysis. If you do see it offered and have a chance to take it, I really recommend taking a look at that because it is a really fun class. And so with that, I'll open it up to you guys. Do you guys have any questions on anything I talked about today, anything about reverse engineering or other careers in cybersecurity that I could help answer? Anything for you guys? And online as well, we've got a speaker so I can hear you guys.
Did you mute yourself on Zoom?
Sorry, what's that?
Did you mute yourself on Zoom?
No. You are muted.
So we're using the room audio.
Oh, okay.
And I'm sharing from my screen, from my laptop here.
I'm sure somebody like that would have stopped us 30 minutes ago.
Yeah. Or everyone's just pretending to pay attention online.
For anybody who is on the Zoom call, you can come off of mute and we'll be able to hear you in the room if you have questions. And if you're uncomfortable doing that, you're free to also just drop it in the chat and I'll read it for you.
I can stand up here and dance for you guys if you want. I just wowed everyone with everything that I talked about.
You know a dance? Can you do the Cupid shuffle?
There's a reason I work with computers.
Is there a cybersecurity dance that I don't know about?
Yeah, it's avoiding standing on the side of the dance floor and just awkwardly watching.
What's a project you're currently working on at Patel?
Good question, and I'd love to answer it. Unfortunately, about 90% of the work that Patel Cyber does is classified. I can't talk about specifics, but but the stuff that I do, very similar, like I said, that router example, very similar to stuff like that. So oftentimes I will be given just a random device, just sat down on my desk, and somebody says, all right, tell me everything you can find out about this in a week. And then I'll just dig into it, both from a hardware perspective and a software perspective. So from that perspective, again, I just treat it like a CTF problem. Assume that somebody's trying to hide some data from me and just dig into it and see what I can find out. Usually, again, we present ourselves with some questions to say, okay, how do I give it data? What input and output are you looking for? What ports is it listening on? Are there any debug pins or pads that I can hook up a multimeter to and get some data out that way? But ultimately, that's exactly what I do all day, is just take IoT devices, operating systems, programs, and pull them apart like that. So some specific examples, I don't know that I can, yeah, that's probably all that I can probably say on that. We do this, I guess another good question is, who pays me to do this? Why do I do this stuff? And there's a couple of different places that do it. One might be a corporate entity like D-Link, not necessarily them, but other organizations like that make a device, and they want to see, if an attacker goes after their stuff, how easy of a job would they have? Or can you find the vulnerabilities in my system before an adversary does? So in that case, we are often given a device and said, okay, please, assume you're an attacker going after this device, and how would you exploit this? How would you compromise this and get malware installed on it? And that becomes a really fun project for us because we actually get to be, the hackers that we dream we are.
There's a couple of questions on chat.
Awesome. Are introductory cyber classes on LinkedIn or Coursera courses useful in any way? I see certificates offered and you take a series of courses. So that's an interesting question, Chris, and it's going to be hard for me to answer that one generally because, like I said at the beginning of this, cybersecurity can mean a whole lot of different things to different people. From a corporate information technology perspective, a lot of times those jobs do look for certificates and certifications and stuff like that. And in that case, a lot of those Coursera classes are intended to get you a certification. So from that perspective, if you're looking to get into that field, that is absolutely worth your time. But from my perspective, when people apply to Battelle and they are, certified information technology specialist or something like that, I don't really care about that. It's not related to what I do. I don't care about how to set up a firewall. I care about how to break the software that's running on the firewall. So from that perspective, I don't care about certifications like that. But if you're looking to get into that side of cybersecurity, which I know a lot of people are, there's going to be some future talks about corporate IT in this speaker series that are going to be related to that. That would be useful for you. So Jeff is asking, is code signing like what Apple is doing at the App Store making your job harder? And Jeff, that's another good question. That's an interesting take on it. Code signing makes it harder to get malicious code onto like a platform like Apple's App Store. You have to be a trusted developer in order to put stuff up there. You also have to, when you download code, they're able to determine if somebody intercepted that download before it got to your computer and added anything to it. You can make sure that there's no modifications made to the programs you're installing. All those things make it harder for an attacker. But from my perspective, again, I'm just looking at how the software works and how to break the software. So code signing from that perspective, I don't care about that because it doesn't make my job of analyzing the software any more difficult. All right, broader question, Gabe, nice question here. How might someone without code background learn more about the breadth of options in cybersecurity? And Gabe, I'll throw it right back at you. You're in the exact place to do that. This speaker series was created because people don't understand the options that are available in cybersecurity. So every month, I think they're skipping December, but next semester, every month, there's going to be a different cybersecurity professional talking about what they do in cyber. That's going to be completely different than what I talked about here. And that's a great place to learn those aspects of cybersecurity. Any other questions from anyone online or in person here?
Do you guys generally work with like private organizations, or do you work for the government as well sometimes? or-
Yeah, so the majority of the work that I do at Battelle is for the US government. And oftentimes they're having us validate their systems and devices and critical infrastructure and stuff like that to defend it against adversaries from other, nation states or hacktivists or, terrorist groups or anything like that. So that's primarily where the funding for Battelle goes. We do also do some with corporate, entities, like I said, analyzing IoT devices that are out there, but the majority of the stuff that I work on is Department of Defense related. You use a MacBook when you're working. So at Battelle, we get an option to pick what device we use. A lot of people use Macs because they're very developer friendly. It's easy to write code on a Mac and not have to go through installing a bunch of extra tools. You got a question, Cal?
Yeah, I see your question, Gabe. Is there an email list for the series to sign up for? I think you just saw this on Campus Today. It wasn't on Campus Today. Glad you saw it. Now that I know that marketing channel works. You can sign up for the ICDT email list on the website. I will drop the website in chat right now. If you go to this website, you can sign up to be on the email list, and it's also where you're going to be able to find any of our future events, including this series. You can look at previous cybersecurity lecture series that we have done. Those videos are up there. You can find other events that are outside of this lecture series, but still in the cybersecurity realm. And then there is an entire section of that site developed that goes into cybersecurity canon. So if you like to read, it's got the best of the best selection for all of your cybersecurity books.
Paul's got a very, very interesting question. He said, this is a pretty in-depth one, but a lot of exploit development historically has used a very awesome tool called Immunity Debugger to debug software. Bob, I think one of the things that I am not particularly qualified to answer is like Windows-based malware, which is one of the things that Immunity is really good at debugging. I primarily focus on Linux-based systems. And so from that perspective, I utilize GDB and LLVM and other tools like that to do my debugging. And from that perspective, nothing is ever going to beat GDB for the amount of functionality and capability that it has. But on top of that, Ghidra and IDA, the corporate comparison to it, both Ghidra and IDA do have built-in debuggers that are intended to help you analyze code and debug it dynamically in real time. And I see those being used a lot in the exploit development world.
Thanks.
Yep, absolutely. Well, any other last questions for me before I get out of here? Awesome. Thank you guys for paying attention, and hope you learned something new today. If you guys want to take pizza home, please do, because I'm just going to throw it away when you guys leave. So I ate Adriaticos for 4 years straight while I was here. I can't do it anymore.
Bob says he'll take a slice virtually.
Perfect.